All right, let me share my screen. Let's get started. How's everybody doing today? Oh, that's right, everyone's on mute. Cool. Well, maybe you can answer this for me. How many of you guys are Android users? If you look at that button at the bottom of your Zoom toolbar, you can find a button with reactions on it. If you press the thumbs up, you can let me know. Cool, so there's a lot of Android users here, so a lot of you will probably see the usefulness in this next presentation. So what we're gonna go over today is mobile app development. And I'm really excited to offer this class because it's really engaging for students. Now, let me go ahead and get this started. Sorry guys. All right. So there's a few things I want to go over today, and I want to keep it kind of interactive. The first thing is why we're doing mobile app development. Let me try and just change. Sorry guys. My meeting controls are in the way. All right, so the purpose of this class is to expose students to basic concepts in computer science in the context of mobile app development. It's a pretty good way to teach because oftentimes these concepts are pretty abstract, but when students see that their code is creating changes in the physical world, it adds a whole nother dimension to the experience. The platform we're using for this is MIT App Inventor 2, and it allows us to design programs for Android in a block-based language similar to Scratch. It's designed for students that maybe have programmed in Scratch before or have at least been exposed to a little bit of another programming language. But even if you're completely new to programming, you should be able to pick up this class and get started. And so I wanted to actually demonstrate a little bit about how the platform works today and possibly give you guys the opportunity to test it on your own Android device if you have one. Before we get started, I want you guys to take a moment, and if you have access to the Google Play Store, go ahead and search up MIT AI2 Companion app. This is the app that allows us to connect to the platform we'll be developing on. By the end of the presentation, if you have that installed, you will be able to test the app that we just created. So quick demonstration, it's going to be very stripped down. I'm going to go very quickly because you only have 10 minutes. We're going to create a small little voice memo app which holds on to speech. And when you press the play button, it's going to overwrite whatever speech. When you press the record button, it will overwrite whatever speech was recorded. When you press the play button, the phone will read out the speech. So we're going to make use of a lot of the phone's sensors. So when we first enter the MIT, let me go ahead. AIT App Companion, we can go ahead and create a new project. Once we go ahead and create that project, we can go ahead and open it up. We have this interface where you can see, let me see, can you guys see my screen? It's not really indicating that it's sharing.
Yes, we can see.
Cool.
Right here.
All right, cool, thank you. Awesome. So once you see this phone pop up, you can actually add interface components to it. If you look at this palette, we have components that are part of the UI, components that control the layout, and we also have invisible components, which allow us to do things like access certain phone sensors, or the speakers, or the camera, and things like that. It's pretty amazing what you can do once you have experience with all these components, but we're going to start out with something very simple. I'm just going to add a couple of buttons. I'm going to add 2 buttons. You can see over here in the properties window, we have a lot of things we can change about these buttons. I'm going to start by changing the text. I'm going to make the first button a record button. I'm going to make the second button, go ahead and press enter, a play button. I'm also going to edit these properties over here because this is going to be what we see when we actually start programming the behavior of each of our buttons. So I'm going to rename that to record and play. So we're going to need a couple other components here that are not going to be visible. If we go to media, we need something to pick up speech when we recognize it, and we're going to use the speech recognizer component. This is an invisible component, but you can see it's present over at the bottom of your phone. We also need a way to play back that speech, so I'm going to go ahead and get this text-to-speech component as well. Now, we're done designing our app for now. Obviously, there's plenty of ways you could expand on this, but we're going to come back to that later if we have time. So, when you want to change the behavior of something in your app, it's going to be very similar to a Scratch-like interface. If you've used Scratch before, we have all the blocks that allow us to use conditionals, logic, we can do arithmetic, we can do logic, we have some data structures we have access to. But we're going to start out by going ahead and clicking on our components. So if I click my record button, you can see we have quite a few blocks that allow us to do some event-driven programming. I'm going to keep it simple for now. I'm going to say when we click the record button, I want to do something. And what I want to do is I want to start recognizing speech. I'll go over here to my blocks associated with my speech recognizer component, and I'm going to call the speech recognizer, telling it to get some text. After that, I need a way to play back the text. So what I'm going to do is I'm going to say when the play button is clicked, I'm going to call the text-to-speech component. Now here we're able to add a parameter to the text-to-speech component, and I'm going to go ahead and use the speech recognizer. I'm going to get the result. Now, if I want to test my app, there's a few different ways I can do that. One way is through this companion app that I just asked you guys to download. If I go ahead and if I go to My Projects, I'm going to go at, not My Projects, if I go to Connect, and I click on AI Companion App, it's going to pull up a code that we can use. But you can also use an emulator. I'll probably demonstrate that in a minute. And you can also connect through USB. Can you guys see that QR code on the screen? If you open up your companion app, if you have it downloaded, you can go ahead and take a picture of this code. I'm also going to paste a link to this 6-digit code. There should be an option to use that into the chat. And let's see. Well, let me paste for some reason. JB. MZGF, cool. Is everyone able to get that 6-digit code?
Yes.
All right. So if you have that 6-digit code, you should be able to access this app and test it out on your own phone. If you have issues with it, I encourage you to kind of send them to Ujwala because we don't have enough time to debug all of it together right now. Part of the class would be to debug those issues together. One of the objectives is for kids to learn how to identify and articulate an issue, and also to take steps to experiment and see what's wrong and try to correct the issue. So there's also an emulator for those that don't have a phone. Of course, I recommend the phone because that gives us access to all the sensor hardware, which is one of the best parts about this class. But if you wanted to connect to the emulator, it would be as simple as downloading it beforehand. There's some instructions I can provide for that. And then you would have to start it. It takes about a minute or two. I have it popped up right now. I'll show you guys what it looks like, but I'm not going to wait for it to load all the way. And it looks like, let me go ahead. For some reason, it won't let me transfer it over to my Zoom screen and share it. But if you want, you can try that emulator as well on your own time. All right, so I want to give a quick overview of some of the topics that we're going to go over during the class. So on the first day, We do a project that starts out similar to what I just showed you, but we're going to add some more functionality to it. They learn about variables, events, and conditionals, transforming some of the text before they read it back. On day 2, they work on a drawing program where we teach Cartesian coordinates and how to edit the pixels on the screen. On day 3, they make a simple game that involves uploading assets, learning how to repeat instructions using loops, and carrying out certain animations. And on day 4, they learn how to build an autoresponder and access some of the SMS functions. They also learn a little bit about lists and arrays, and also how to persist data. That means save it so that you're able to use it later on in your program, even after closing it down. And on day 5, we go a little bit into how to use the GPS functionality, and a little bit into API calls using this web viewer component. Now, obviously, there's a lot that's going on here. It's designed such that if you're a beginner, you have enough to get started. But if you have some programming experience, there's plenty of room to expand on what you already know. There have been some pretty awesome projects that are created in MIT App Inventor. And so really the sky's the limit with what you can do. Just because it's block-based doesn't mean that there's nothing you can do with it. It's actually a very, very useful platform.